So this is what the magnetic starter looks like on my Jet table saw before I did any modifications on it. I want to just walk through the internals a little in the circuit flow path because all the YouTube videos that are out there don't really go quite into the detail that I would have liked when I was trying to figure out how this worked. So the cover of the box is just held on with 2 screws. I've already loosened them, so don't be alarmed by the shakiness. Inside the cover, there are 2 metal paddles. This is for the off switch, and this is for the on switch. Off, on. One of the problems with this box is that the off switch and the on switch are the same size, and it's very small, and it's not that easy to hit when you're sort of looking for it and trying to keep your hands on the workpiece. So that's going to be modified, and I'll show you that in a bit. Here is the internal box. This is the contactor. We talked about that already. And then this is the thermal overload protection. We've talked about that as well. This is the grounding bus bar. And just so it's clear, this side of the wiring and this line is the hot from the wall at 240 volts. And then this leg over here is the power to the motor, also 240 volts. There's no neutral, so it's just the 2 legs of the hot of the 240 volt high and low, black and white. White up here, and the black is very hard to see because it's black, but it's over here. All the red wiring is the energizing circuit. The energizing circuit for this relay contactor is also 240 volts. It's line voltage, which is convenient for this little trick that they use to keep it the energizer circuit powered. So just to quickly walk through the way this all works is you got your nominally high line coming in through this wiring. It's bridged over to this terminal, which is the energizing circuit. This wire runs all the way to this little terminal back here, which is A1 on the wiring diagram, and this is the relay contact, one of the sides. The other side of the relay energizing circuit is A2, which there's a terminal over here in the back and down here in the back, and this one down here is the one where it's connected to, so let's jump over and follow it to there. So this little terminal is connected over down here to this leg of the thermal overload switch. And this thermal overload switch, terminals 95 and 96 are normally closed, and 97 and 98 are normally open. The wiring diagram is wrong. God only knows why, but it's pretty clear on the side of the thermal overload which one's normally open, which one's normally closed. And it's actuated by this blue button with this potentiometer on it. This is what gets pushed by the off switch. When you push that, it breaks these 2 connections. And so the A2 terminal comes into this terminal right here. And then that's because it's normally closed, it goes back over to here, which runs into this normally open terminal 14. Now, let's get the switch out of the way. This is normally open, so if you follow where that goes, this red wire, normally open terminal, and if you follow just this leg, it goes up to this normally open terminal, which is then bridged over by a little metal bridge back here to this terminal, which is tied to the low leg of the 240 volts, completing one full low voltage, or not low voltage, sorry, one full relay control circuit. This switch is the on switch, and this button is what's pushed by the on paddle. And the way the energizing circuit turns on is when the legs are hot. You've got one full circuit except for across these 2 terminals or these 2 terminals, and these are in parallel, as you can see. So if either one of these legs gets made, the energizing circuit turns on. However, this leg is on the contactor, so it shouldn't get turned on unless you physically go in and push this sucker, or you energize across the 2 relay energizing terminals, which is what this switch is for. So when you close this, it momentarily sends power from this leg to this leg, which, if you just pretend this isn't connected, is essentially connecting this leg to this leg, which then, completes the circuit and turns on the relay, which goes in like this. But what happens when you let go of the button? Well, because when you push this button, this relay goes in because you've completed the circuit. When you let go of this button, because this is still closed and this is still completing the circuit, then this keeps the relay energized, and it basically self-closes itself. So then the question is, how do you turn it off? Well, all you have to do is break it down here, and then these two normally closed contacts open, and because it's relying on a complete circuit from down here, through here, up through here to here, breaking this circuit right here closes this energizing circuit, or opens the energizing circuit, and the contactor releases, and the saw shuts off. It's very clever. A lot of the videos I found don't really talk about that aspect of it, but it took a little noodling to figure out how that worked, and that's why I wanted to open this up and show you. Just to talk more about the parts in here, this is the part of the thermal overload switch that lets you set what your nominal or service amperage is for your motor, so you know how much power you can put through it before you burn it out. I have no idea what this is, and I have no idea what this either of those potentiometer switches are for, so I'm not even going to talk about them. For the mains saw power for the motor, you've got this leg here and this leg here, and ignoring the low voltage or the energizing circuit stuff now, we're just looking at the big stuff. You have these two that go through the contactor through to these two terminals down here, which then are hardwired from this thermal overload switch to go through straight down to the back to these terminals down here, which then run straight into the motor wiring, and that's how the motor gets powered. And then because you have this thermal overload switch in series, it has to run through the thermal overload switch. And there's bimetallic switches in here that pop open if there's overheating. So that's all there is to this. And we can, in the next video, we'll talk about the modifications I made.